So now let's solve question 3. So we know that the function f defined like this f function is the squared error function. Our goal will be to minimize f over the over the plane R2. Okay. So we immediately note the following. Since we're working over R2, there is no need to use Lagrange. It will suffice to find AB such that the gradient of f at AB is equal to 0, 0. So let's do that. For partial of f with A equaling to 0, that's the first thing we want. So that's saying 0 is equal to sum from 1 to k 2 yi minus a xi minus b times minus xi and then for partial of f with b, you get this. Sum to yi minus a xi minus b times minus 1. So the first thing we'll do is we'll work with this second equation here because this is easier to work with. So this one I'll box it off for now. This one will be continued down here. So I'll get rid of the 2 and the minus 1. And then you can observe this. So put this summation together, and then the summation of b, constant b k times, that's just kb. So then if I move kb to the other side and divide by k, I get this. But then if you keep simplifying, you notice that I just have y bar minus a x bar. So that's what my b value is. Then I take this b value that I found here, so this b value, and I'll substitute it all the way up there from before. And then I'll simplify that expression, and I'll see what I can get for a. So then, so the other expression was this, the sum from 1 to k, yi minus a xi minus b times minus xi, but the minus xi, the minus sign doesn't really matter, so I could divide it out by minus 1. So this just becomes an xi. And I'm substituting in the b. From above. So then this becomes yi axi minus y bar minus ax bar. And this entire thing times xi. I believe that's what b was. Yep. And then I rearrange the terms. Or I could split apart the terms right now, actually. So that's xi, yi. A times xi squared and then the next term would be xi y bar, and the last term will be a plus a xi x bar. But we could view the a, x bar, and y bar to be constants. So here's what I mean. So divide by k, multiply by k, you get this. And same thing, you divide by k and multiply by k. So you get this. And then you isolate for the variable a and you simplify. So from there, a would be equal to sum xi yi plus, not plus, sorry, minus divided by sum 1 to k xi square minus x bar. There should be a k here. Oh yeah, here I forgot to write. There should be a k. There should be a k in front of this. So let me fix that. There. And that finishes the question. So your A looks like this, and from before, B is like this. So then, L of x, which equals to ax plus b, with the values of a and b that we just found, will minimize the squared errors of the points x1, y1 to x and yn. So this is the line of best fit, or as your question calls it, what does your question call it? The linear least squares fit. Same thing. This Lx is the linear least squares fit, or line of best fit, if you've taken stat course before. And that's the end of question 3.